Now, as long as we're talking about batteries, I thought it might be interesting just to show you a general manufacturing process for lead-acid batteries. This is nothing specific, but if you're not interested in this, go ahead and just skip past it. This is kind of a flow chart of how the batteries are made at a very high level. This particular battery here, the pure lead portion, is what's most important. That's a pretty unique process. I haven't really seen that anywhere else. But the first thing that you need to do is to make the lead, process the lead for the battery. So you put it into strips of some sort, and the thickness of these lead plates and such kind of determines the battery characteristics. If you just have a solid plate of lead, its surface area is very low, so it ends up with a very high internal resistance. That makes it a not very useful battery. So you need to do something with it. In this case, they perforate it. You basically make a punched sheet with corrugations on it, which allows you to have more surface area, and it allows it to better hold the paste, which is the next step. You then have a lead paste that you put onto these plates. The positive and negative plates are largely the same at this point, as far as I understand. But you put this soft lead paste onto those plates, and the plates, the rigid lead, are just there to hold everything together. The paste is what does most of the work. The rigid portion of it is just there to conduct the current to where you need it. Stack the plates. This looks like it's an automated process on this particular company. Lots of them are not automated. You cure the plates, put it into an oven. You assemble them into a stack. And here's a stack of assembled plates. And this is generally what you'll find inside the battery. You cast on the battery straps, internal straps inside the battery. If you open up the vents on a vented battery and take a look inside, you can see those. This particular company puts it through a test step. And then this is their proprietary technology for assembling it. Fill it with acid. They say that they use a high-grade electrolyte. I don't really know what the grade of acid matters necessarily, but it does need to be pure to avoid self-discharge. That's perhaps how they get their 2-year shelf life, part of it, in addition to the pure lead chemistry. And formation is really important. And this is a step where a lot of companies cheap out on the batteries because it's a very time-consuming, expensive step. You can see in this graphic here that they have just row after row after row of batteries sitting here on chargers. This is what actually forms the lead plates, makes the positive positive, the negative negative, and if you form it longer, you can get a better battery. If you don't take as much time to form it, you get a cheaper battery. And this is a good portion of the reason why there are different grades of batteries. It's how well formed they are. I'm sure a chemist will tell you that I'm wrong, but that's my basic understanding of it.